In this lecture, I am going to talk about arrays. In Solidity, we have two types of arrays. We have fixed size arrays and dynamically sized arrays. A fixed size array has a compile time fixed size. This means that we must specify the number of elements of the array at declaration time. If we say, for example, we declare an array with 5 elements, that array has 5 elements. We can't make that array to have 6 elements or 7 elements, so it's fixed size. We have two types of fixed size arrays. The first type of array has its elements saved as a low-level byte encoded in hexadecimal. Then the second type of array has its element of type signed or unsigned integers. This type of data, fixed size array, has a member called length, which represents the number of elements in the array. It's important to note that, like in any other programming language, elements of an array starts from index 0 and not from index 1. Let's see an example. I've declared two fixed size arrays, x and y. X has 2 elements and y has 3 elements. Then I created a function, a public function named setX_y that modifies these two arrays. I deploy this contract and pressing on X is public, so automatically there is a getter for it. We can see that both elements of the array are 0 because an uninitialized array will have its elements equal to value 0. So the first element is 0, 0. This is in hexadecimal, and the second element is also 0, 0. This is the first byte of the array, and this is the second byte, the last byte of the array. When I press on setXY, I called this function and it modifies x. So the first element of the array will be A and the second element of the array will be B. But these bytes will be represented as hexadecimal ASCII codes of A and B. So let's see what is the hexadecimal code for A. So I look for ASCII codes. Okay, let's take an example from here, and we can see that A, lowercase a, is 61 and lowercase b is 62. So our array X should be 61, 62. Okay, let's check it. As you can see, our array of 2 elements is 61, 62. 0x indicates this is a hexadecimal representation. If I want to see the value of Y array, we can see that it's also represented in hexadecimal. So the Y array has 3 elements. But here I wrote y equals 3. So in fact here I have something like that. The first element, the second element, and the third element. This is the real representation. Yeah, this is an error. I can't write something like that in Solidity. This is not permitted. But this is how it's represented internally. This is the first element, this is the second element, this is the third element. And please take care that it converts and saves the decimal number I wrote as a hexadecimal number. What does it mean? For example, if I have y equals 16, and I deploy this contract one more time, I call that function setXY, and I want to see the value of y. What do I see? We don't have here the 16 value. We have 0, 0, 0, 0, 10. Why is that? So, this is the first element of the array, 0, 0. This is the second element of the array, 0, 0. And this is the last element of the array, 10. Why is 10? Because 16 in hexadecimal is 10. If I write 16 to hexa, 16 is 0x from hexadecimal and 10. This is why we see here this number. Then I've created this function named getX that returns an element of the array. It has one argument, that is the index of the element I want to return. For example, if I call this function like getX round brackets 4, I will return the element from index 4, and that means the fifth element, because we start indexing from 0 and not from 1. So the first element has the 0 index. Let's see how it works. For example, I want to see the first element of X array. We can see that the first element is 61. Why is 61? Because A has an hexadecimal ASCII code of 61. The second element means the element with index 1 is 62. Of course, the hexadecimal ASCII code. If I want to get the third element, I will get an error because there is no such an element. My array has only 2 elements. You can see our virtual machine, our Ethereum virtual machine returned an invalid opcode. This is an out-of-boundary error. If I call this function without specifying an argument, and I have an argument of type integer, my argument will be by default 0 and it returns the first element. So getX, it returns the byte 61. Another function I've created is get_x_length, which returns the length of the array, of my array, of X array. So get X length, my array has 2 elements. Okay, we can modify a byte from a fixed size array like that. If I uncomment these lines, I'll get an error. This won't compile because it's read-only. I can modify the element from position 0, the first element. Let's see in another example how a fixed size array of integers works in Solidity. I'll declare an array of integers with 3 elements. Int, square brackets and the number of elements, and then the name of the array. Of course, I can have a visibility specifier like public here, and then the name of the array. Let's say again X. Then I create a function set element unsigned integer I public. This is a function that modifies my array. An integers array is not read-only, we can modify it. And here I will modify the element at index I. So I'll add here another argument, the value of the element. So for example, int value, let's say. And now X square brackets Y, this is the index, equals value. Let's test it. I deploy the contract. This is the last deployment. And now I say, okay, let's see what is the value of X. The value of X, because X is not initialized, is 0. This is the first element. This is the second element. This is the third element. All elements are 0. This is the automatically getter that was created. And now I want to modify the second element. This is the element from index 1, and the new value will be 45. I call the function, and now what is the first element? 0. What is the second element? 44. I've modified that value. Of course, if I want to modify an element that doesn't exist, for example, I want to modify the 10th element with value 66, I'll get an error. This is an error because my array has only 3 elements. Okay, this is how we modify a fixed size integer array. Then if we want to return an element of the array, we create a getter function, or if the array is public, that getter function is automatically created, like in our example. At the end of this lesson, I want to show you another way of initializing a fixed size array. So here, where I declare the array, I can say equals, And now between square brackets the elements of the array. So 10, 20, 30. My fixed size array has 3 elements and those values are 10, 20 and 30. Let's delete all deployments. I deploy the contract one more time. And now I want to see the value from index 0. And we can see there is 10. The value from index 1, so the second value is 20. And the last element of the array, so the element from index 2, is 30. Okay, that's all for the moment. We'll talk in the next chapter about dynamic arrays.